Alright, this is a continuation video from the previous content, which was graph transformations, but it was just vertical and horizontal shifts, which we see right here, vertical shifts, horizontal shifts. We already know what the form looks like, so now we're going to talk about the new stuff. Y-axis flip, x-axis flip, and a shrink or stretch. Basically, all of these deal with a number being multiplied to the function. A y-axis flip is when it's multiplied by a negative. So we're going to take our function and it's going to be multiplied by a negative on the inside. Okay, so that's going to take our graph and flip it about the y-axis. So an x-axis flip is when we multiply a negative on the outside of the function. And it's going to be a flip over the x-axis. Okay. Again, this will make more sense when we start doing some graphs. And a shrink or stretch. So it's still being it's a number being multiplied to the function. So let's just do it's a times f of x. So if the absolute value of a, meaning the distance away from 0, if that a is bigger than 1, if the absolute value of a is bigger than 1, it's going to be a stretch. That means it's going to make the graph taller and more skinny, just like if you would stretch out a piece of Play-Doh. And if the absolute value of a is smaller than 1, so we're talking about fractions and whatnot that are less than 1, it's going to be a shrink. So it's going to get nice and short and fat, just like if you're kind of crumping a piece of mud together or something like that. Okay? So these are our 1, 2, 3, 4, 5 transformations so far. I'll explain something more in depth in the next slide. Alright, since we have a whole bunch of different transformations, it's important to pay attention to the order of transformations. Just like the order of operations, where if you don't follow that rule, or those rules, you will get a wrong answer. Just like for graphing, if you don't follow these order of transformations, chances are that you're going to get a wrong graph. Alright, so the first thing we do is we always take care of the x-axis flip first, then our shifts, then our y-axis flip, and then our shrink or stretch. Now for this section we're just going to be sketching a graph, so it doesn't have to be super accurate, but you should have the transformations at least really close. Here's an example of what we're talking about. Say for example you were given name the parent function, describe the transformations, and sketch the graph, and you are given the function below. So look at number 1. What is our parent function going to be named? Parent function. Basically what a parent function is the function without any of the shifts, flips, or any kind of transformation. So looking at this guy, think back to our most common functions. So in this case our parent function is going to be y equals x squared. Just looking at this little squared here. Okay, so now we got to name our transformations. This is when we got to start analyzing the function. We have a negative being multiplied on the outside, adding 2 on the inside, and subtracting 4 on the outside. Well, we can take care of these addition and subtraction right away. So this adding 2 on the inside, that's saying it's going to the left 2 units. This subtraction on the outside is saying it's down 2 units. Oh, down 4 units, sorry. And this negative being multiplied on the outside, that is describing a type of flip because it's a negative number being multiplied. Now that's on the outside, that's going to be a x-axis flip. Okay, and we're not multiplying the equation by anything except for -1, so I think that's it. Now I'm just going to sketch the graph. Alright, I think it's always easy to plot the graph with a parent function first. That way it's nice and easy to guesstimate our new function. Okay, so that's the sketch of the parent function. Now we're going to do our shifts. Now, looking back into the order of transformations, we got x-axis flip that goes first. So we're going to take this graph, we're going to flip it over the x-axis. So all this stuff is going to flip to this side. Okay, so I'm just going to do a rough sketch because it's not final yet. We have more transformations. We have left 2 units. So it's going to go to the left 2. And it's down 4 units. So we're going to take this point here, move it to the left, down 4. So to the left and down 4. It's about there. Now we're just going to sketch our graph. And that is negative x plus 2 squared minus 4. Okay, so we just sketched our transformation based on the parent function and the types of transformations we had. Okay, one more problem. It's basically the same idea. I gave you a function. I want you to tell me what the parent function is and what all the transformations are. Okay, so the parent function is the equation without any of the transformations or flips or what have you. So looking at this guy, I'm going to say that the parent function is the cubic. Okay, now transformations. Let's see here. Do we have any flips? What kind of flips do we have? Well, we have a negative being multiplied to the x on the inside. So it's a negative x, so that's going to be a y-axis flip. Do we have any translations? So we're going to left, right, up, down. If we're subtracting on the inside, we're subtracting on the inside, so that's to the right 3. We're subtracting on outside 2, right here, so that's down 5. And we're multiplying on the outside of the function, so that's going to be a stretch or shrink, blank there. So we're going to look at the absolute value of 2, and that happens to be bigger than 1, so this is going to be a stretch. Now it's time to sketch the graph. Okay, so the cubic function originally looks something like this. Redraw that link. Well, the cubic function looks similar to this. Okay. So that's just the graph of the parent function. I'm going to make that dotted line. Now we're going to base our transformations off that graph. So looking back at the order of operations, you'll see that the x-axis flips come first. In this case, we don't have one. So next comes the shifts. So we have a right 3 and down 5. So we're going to go to the right 3 and down 5. Right 3, down 5. Again, we're just estimating right now. So it's going to go something like that. And again, we're not done yet. I'm just going as I go because I think it's easier to take it step by step. Then we'll have a y-axis flip. So it's going to flip about the y-axis. So it's going to come, everything over here is going to flip over to here. A mirrored image. So it's going to look something like this. I'm not done yet, so I'm going to dot it. And then a stretch. So that means it's going to make it taller and skinnier. Okay, that's not the most beautiful thing in the world, but it's close enough. I got the flips down, I got the stretch, I got the shifts, and I think we get the good idea.